In this lesson, we will be exploring solving absolute value equations. Before we can begin discussing the process for solving absolute value equations, let's recall what the absolute value means. So the absolute value of a number is the distance from 0 on a number line in either direction. An absolute value equation, which is an equation in the form of ax plus b inside the absolute value bars equals some constant c. We can solve this type of equation by solving two related linear equations, and that's what we will be practicing in this lesson. So for values of c that are greater than or equal to 0, so that means this c value is either 0 or anything larger than 0, so 0 or a positive number. Then if x is a solution to this equation, ax plus b equals c, or ax plus b equals negative c. Those are going to be the two types of equations that we set up, one that looks like this, one that looks like this, and then we're going to solve each one separately to get two solutions to the absolute value equations. For a value of c that's less than 0, let's think about what that means. The absolute value of something, some quantity inside here, equals c. If c is a negative number, that doesn't make any sense because we know that absolute value measures the distance away from 0, and as we've discussed before, the distance away from 0 should always be a positive number. So if this value of c is less than 0, that means it's negative, and that doesn't make any sense. So an equation in that situation would have no solution because there's no value for x that we can find here that will ever make the absolute value of that quantity equal to a negative number. And we'll explore that in a little bit more detail throughout this lesson. Okay, so let's remember that anytime we're solving an equation, that means we are trying to find the value or values of x that make the equation work. So in this first equation, the absolute value of x equals 8. So we are trying to find what values of x will make that true. So in this one, excuse me, there are two possible values. X could be 8, or x could be negative 8. Because if x is 8, think about it. If we have an 8 here, the absolute value of 8 equals 8. Or if we had a negative 8 here, the absolute value of negative 8 equals 8. So in this particular situation, we have two possible solutions for x. Okay, let's take a look over here at number 2. Here it says the absolute value of x equals negative 10. And let's stop and think about that for a minute. We're trying to find a value or values of x that will make this true. If they want us to find the value for x that will make the absolute value equal to negative 10, will that ever happen? No. The absolute value is always going to come out to be a positive value because it's measuring a distance. So in this equation, we would say no solution because it's not possible. There's no value of x that we can find that's going to make the absolute value of x equal to negative 10. So in this case, we would say no solution. Okay, because the absolute value of a number is never going to give us a negative result. Okay, in number 3, we're going to be looking at an equation that is a little bit more complicated. Instead of just having the x inside the absolute value bars, now we have this entire quantity, x minus 2 equals 5. Okay, so if the absolute value of x minus 2 equals 5, we need to find what values of x are going to make that happen. So the way that we solve this is we're going to find what value of x will make that quantity, x minus 2, equal to 5, or what value of x, x minus 2, will make that quantity equal to negative 5. Because if this quantity equals 5, the absolute value of 5 is 5. If this quantity equals negative 5, the absolute value is still 5. So we need to find two different values for x. We're going to solve this equation, and we're going to get one possible answer, and we're going to solve this equation, and we're going to get a second possible answer. So now we are utilizing what we know about solving equations. We need to isolate the variable. We need to get the x alone. So x minus 2 equals 5. We add the opposite. These cancel out, so 5 plus 2, 1. Possible solution is 7. And we come over here to the second equation. Again, we need to isolate the variable. The way that we're going to do it, the way that we're going to solve, is exactly like the first one, but our solution will be different because now we have a -5 on the right. So -2, add the opposite, we do +2, cancel out. -5 plus 2 is -3. So the two solutions that we have for this absolute value equation are x equals 7 or x equals -3. Okay, let's practice another one. Here we have the absolute value of x plus 3 equals 5. So again, our goal is to solve this. Our goal is to find a value for x that will make that quantity equal to 5, or a value for x that will make that quantity equal to -5. Once you have set up your two equations, you don't have to think about the original equation anymore. You're just going to solve this one, find one solution, solve this one, find the other solution. Okay, so we draw the line. We need to isolate the x. We add the opposite. Cancel out. 5 plus -3 equals 2. So one solution is 2. Again, we're going to solve this one. Same process, but we will get a different solution. -3, -3, cancel out. -5 plus -3 is -8. So the possible solutions to this absolute value equation are x equals 2 or x equals -8. The example we see here in number 5 is a little bit more complicated, but the way that we set it up and the procedure we follow is exactly the same as what we've done in the previous examples. So we're going to take the quantity inside the absolute value, 4x minus 2 equals 6. So we need to find what is the value for x that will make this quantity equal to a positive 6, or what is the value for x that will make this quantity 4x minus 2 equal to -6. And again, once you set up your two equations, you don't have to think about the original equation anymore. You're going to solve these two and you'll get your two solutions. Okay, so we need to isolate the x. This is a two-step equation. Plus 2 on both sides, add the opposite, cancel out. We bring down 4x equals 6 plus 2 is 8. Now we need to cancel out the 4. So we're going to divide on both sides by 4. Those cancel out. 8 divided by 4 is 2. One possible solution for x is 2. Or now we're going to solve the second equation to find the second possible solution. And again, the procedure is the same, but since we have a -6 over here on the right, our solution is going to be a different value. So -6 plus 2 is -4. Again, we're isolating the x. Divide by 4 on both sides. It's division. Divided by, cancel out. -4 divided by 4 is -1. So in this equation, the two possible solutions are x equals 2 or x equals -1. In this last example, we take a look, and it appears to be the same type of situation that we've looked at on the previous pages, except when we look, we have absolute value of 3x minus 2 equals what? This one equals 0. And so what we have to recall is that absolute value is measuring the distance away from 0. So what this is saying is that the absolute value of this quantity equals 0, which means it is 0. Okay, in the other examples, it was telling us how far away from 0 was this quantity. In this situation, it's 0 units away, so it's actually on the 0. Because of that, we are just going to solve one equation. In the other examples, we had to take the positive value, and then we also had to find the value for x that would make it equal the negative value. Because we know 0 is neutral, 0 is neither positive nor negative, we are just going to solve a single equation here. So in this one, there's only going to be one solution for x. Okay, so we isolate the x. We need to do plus 2, add the opposite, cancel out. We have 3x equals 0 plus 2 is 2. We divide both sides by 3. These cancel out. If we did 2 divided by 3, we're going to get 0.6666 repeating. So we know we put the bar above. So we have two choices. We could just write the fraction, 2/3, or we could write the decimal value, 0.6 repeating. Either solution is fine. Okay, so in this case, there's only one solution, and the reason is when it equals 0, there's no need to set up two different equations and solve them. So the single solution to this equation is x equals 2/3, or we could say x equals 0.6 repeating.